All right, today we are going to take notes on Chapter 4, Lesson 4. We have parallel lines and perpendicular lines. If you don't have these notes out just yet, pause the video and grab these notes. We're going to fill them out together. So this is a shortcut for the word parallel. It looks like the number 11, but I think it really comes from the L of parallel lines, where they kind of look parallel. Perpendicular has a shortcut. It looks like an upside down T. So if I write this, that's the word perpendicular. All right, let's talk about the slope of parallel and perpendicular lines. Well, if parallel lines never cross, then they are going to have the same slope. So whatever the number is in front of x, the m, they're going to have the same m. So if one slope is 4, the other slope will be 4. If one slope is negative 2/3, the other slope will be negative 2/3. If they never cross, they have to have the same slope. They have to be slanted in the same direction. Okay, perpendicular lines, on the other hand, they have opposite inverse slopes. Opposite inverse slopes. So what this means is that they're going to be flipped and the signs will be different. Okay, so here's some examples. If one slope is 2/3, then the opposite would be negative. The inverse would be 3/2. So I have flipped it and I've changed the sign. If one is positive, then the other one is negative. If one is 2/3, the other one is 3/2. Okay, let's say I had negative 1/4. Well, then the opposite inverse would be positive. And if I flip 1/4, I now have 4/1, or just 4. Okay, if I have 7, the opposite is negative. The inverse is 1/7. Because this was technically had a denominator of 1, it was technically 7/1. So now the inverse is 1/7. Okay, if I had negative 2/5, the opposite would be positive. The inverse would be 5/2. So a perpendicular line will have opposite inverse slopes. We're flipping the fraction, kind of like when we divide by fractions, keep, switch, flip. We're flipping the fraction upside down and the opposite sign. Okay, so now the directions say determine whether the given lines are parallel, perpendicular, or neither. So an example, let's just draw a little picture here. If I had my x and y axis, parallel would look like this. They're never going to cross. Perpendicular would look like this. If I have this slope, then this slope makes a 90-degree angle compared to that other one. Everything else just means that they cross, but they cross not at 90, but they do cross. So we've got parallel, perpendicular, and neither. Neither still means they're probably going to cross, but they're not crossing at anything special. Okay, so I come over here. This equation is in slope-intercept form. So I've got my m is 2. My other one, my m is negative 2. Well, they don't match, so they can't be parallel. And they're not flips of each other, so they can't be perpendicular. So this would be an example of neither. They just normal cross, but they're not parallel, they're not perpendicular. Okay, let's see, example 2. Y equals 4x minus 6, and y equals 4x plus 9. Okay, if you look at that one, do you think it's parallel, perpendicular, or neither? Well, m is 4, m is 4. That means these guys are parallel. You can do the shorthand notation for parallel, or you can spell it out. Either one is fine with me. It looks like the number 11, but it's really shorthand for parallel. All right, let's do example 3. We don't have to have an equation in slope-intercept form. We could have an equation in point-slope form. So y minus 2 is equal to 2/3 parentheses x plus 8. The second equation is going to be y plus 6 equals negative 3/2 x minus 1. So in the equations up here, we didn't care anything about b. In the equations down here, we don't care that this says minus 2, plus 6, plus 8, minus 1. The only place our eyes should be focused on is the m. So does the m match? Nope, it's not parallel. Is the m inverse and opposite? Yes. We have one positive, one negative, one with 2 on top, 3 on bottom. The other one's 3 on top, 2 on bottom. So these are perpendicular lines. They cross at 90-degree angles, so they are perpendicular. Okay, let's look at example 4. When the forms don't match, we're not ready to compare. So I've got standard form, I've got slope-intercept form. We need to rearrange this one into the slope-intercept form. That way we can find our m. So I'm going to move my 2x to my 6x to the other side. That leaves me with negative 2y equals negative 6x minus 2. Then I'm going to divide everybody by negative 2. And I end up with y equals 3x and a positive 1 at the back, 3x plus 1. Now I can say this has a slope of 3, this has a slope of 3, therefore they are parallel. But I couldn't tell that they were parallel until I rearranged the top one. Okay, here's our next example. I've got why do I have I shouldn't have a y and a y, I should have an x. 3x plus y equals 8. That one is in standard form, so I'm going to need to rearrange it. Y minus 4 equals 1/3 x minus 2. I don't need to rearrange this one because my m is obvious. Here's my m. My m is 1/3. So I'm hoping that this one is either going to match and be 1/3, or I'm hoping it's going to be opposite inverse. Okay, so let's rearrange the top one. I need to move the 3x to the other side. That makes negative 3x. There's nobody to divide. I now know what my m is. They are opposites, check. And they're inverses, opposite inverses. So these guys are perpendicular. They are opposite and they are inverse. They're flips of each other, and one's positive, one's negative. Okay, example 6. Okay, my equation is 4x plus 2y equals 9. 6x plus 12y equals 8. They're both in standard form, so I'm going to need to rearrange them. I'm going to move the 4x to the other side. 2y equals negative 4x plus 9. Divide. That gives me a negative 2x plus 4.5. Okay, I'm going to move the 6x to the other side. 12y equals negative 6x plus 8. Divide. That gives me y equals negative 1/2 x plus, I could make it a decimal or fraction. I think I'll make it 2/3. Now, I look at the slopes. the M's. I don't care anything about the B's back here. I just need these guys to either match or be opposite inverses. They are inverses, but they are not opposite. So this is an example of neither. Okay, let's take a look at this. If I have a picture, I'm not going to use my eyeballs and just go, I think so. We need to actually prove it using slopes. So I'm going to color code this. I'm going to have a blue line, the blue dots, and the red dots. Okay, so remember I rise first and I run second. So blue is positive. He's up 1 and 1, 2, 3, 4 over 4. Okay, red, I'm going to rise 1, 2, 3, 4 and run backwards 1. So do these slopes match? No. Are they opposite inverses? Opposite inverses. Well, I've got a positive 1/4 and I've got a -4. So yes, they are perpendicular. But I'm not going to do it just off of eyeballs. You have to prove that they were perpendicular with opposite inverse slopes. Okay, these look parallel. Let's double check because we're not just going to use our eyeballs. That's never a good method. So I'm going to go red and blue. So red, I'm going to rise and run. Blue, I'm going to rise and run. Red is up 1, backwards 2. Blue is up 1, backwards 3. So these guys are neither. It kind of looked parallel, but they're not exactly matching slopes. -1/2 is not the same as -1/3. Okay, so you are ready to start the homework. The homework is a worksheet on Google Classroom.